Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to cover some XNurbs tools. Specifically, we're going to talk about Square and Align. And so if you have a studio license and you have access to XNurbs, you'll be able to do this. If you don't, if you're on an indie license or a trial license and you want to figure out whether or not the studio license makes sense, hopefully this will answer some questions. Keep in mind that there are a lot of settings to these XNurbs tools. I'm going to do my best to try to explain the core of them, but a lot of this takes some playing around or understanding some big brain math stuff in the back end. And so what we're going to be doing today is I'm going to talk about a specific example that hopefully will help identify some of these settings. And so the Align tool and the Square tool, both XNurbs, the Loft tool, which we'll also look at, is in all licenses, indie and studio. And so if you've ever played around with the Align tool, probably what's happened is you have started to create an align between two edges of surfaces, and you've gotten a result like this. And you don't really know what's going on or what the settings do. And so you kind of abandoned it and you chose another option. And so let's go ahead and get started first by creating some surfaces. So I'm going to start from scratch. I'm going to do a new file, delete the cube, and zoom in. And then I'm going to go to a front view and just create a spline curve. And so we'll kind of just do something funky like that. Doesn't really matter. And then we'll extrude it. And so kind of pull it back and then move it in the Y direction. Now I'm just going to extrude this again. I'm going to use the same surface for both of these. So it doesn't really matter because it'll help us with the settings. But for the most part, if you want to create a new surface, you certainly can. I'm just going to go ahead and move it down a little bit more. And let's rotate a bit more so it's more vertical. Might help us. Actually, I want to pull it over here. Okay. And then get rid of that. We don't need it. Also, I'm going to hide the overlays because they're not really going to help us here. All right. So in general, if we're trying to connect these two surfaces together, we've got three main tools that we can do it with. Well, there are more ways. There are probably 6 or 7 different ways that we can connect these together. But at the core of it, we can generally loft between them. So I'm going to go to my edge selection and then loft between these. We can use G0, which is just connected. It'll put a straight set of a surface between them. G1, which is tangency. It'll drive the direction of the surface relative to the edges. And then G2, it'll also look at the radius of curvature. Because these are both extrudes, they're fairly flat, or they're exactly flat in that direction. So G1 and G2 generally are going to have more of a visual impact when you actually go into something that has curvature in 3D. And so this case doesn't really work. And so that's a lofted surface. That's a pretty straightforward one. Again, anybody on indie or studio license can do that. The next way that we could do this is with the Square tool. Now again, Square is an XNurbs tool. And the difference between Square and Loft is that we still have the option to do G1, G2 continuity, but the main difference is we've got some control over what they're calling degrees and spans in here. And so degrees and spans are going to be a big part of this video. We're going to try to explain and understand. I'm going to do more of it in the Aligned tool rather than here in the Square tool. But essentially, we need to think about the degrees and spans, which we've got two sets of numbers here to change. We've got a U direction and a V direction. And if you're not familiar with those terms, basically think about an XY coordinate system on a surface. When you use tools like raise degree, or you see the vertices on the screen here, this is essentially the 2D curve, like the spline that we created, that's basically along the surface. And so as we increase the degree, in this case, as we increase it in this direction, or the span in this direction, and the span, you can see that it's adding those CVs, those control points, or control vertices. And so essentially what we're doing is the degrees and the spans are going to add up. And so if we take, let's make this easy. Let's do 5 and 5. And I'll go back down to 5 and 5. Basically what we have is 10 in each direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And so those numbers, the degrees and spans, are going to add together to give you the total number of vertices or CVs that you're going to have on your surface. They do slightly different things. The spans, think about it as the independent number of curves. And so as we lower the degree, but we keep the span, basically what we're doing is we're saying we've got 5 independent curves that are controlling the shape of this surface. Now, as we increase the spans, we're adding more curves. And as we increase the CVs, we're adding more points on those curves. And so, again, both of those add up, give you the total number of CVs. They do slightly different things. Now, I'm not going to save that surface because the main goal here is to really talk about the align tool. But again, there are different ways that you can do this. You can go and do a bridge curve between these edges and G2 continuity. You can do the same on the other side, and then you can use those G2 continuous curves to patch the area between here and drive the tangency, things like that. Again, the point of it is to focus our attention on the align and the square tools. All right, so the first thing to know about align and how it differs from loft or square is that the first selection that we make, in this case, this lower edge of the sheet, this is actually, I'm going to call it sacrificial. This surface is going to completely go away and be replaced with the next one. And so I'm going to select this edge next, and we'll go to our align tool. And you can see that first one completely gone. Even though I selected that upper edge, it's totally gone down here. Don't worry about all this on the screen. This is the continuity analysis. We'll talk about that in just a little bit. But basically what happens is we have said that that entire first surface that we selected the upper edge on, that thing is going to go away, but we're still going to use its information to create our new curve. This is where understanding the degrees and spans plus the extra settings like blend extra row, this is where it really comes into play. Because I, no doubt, the first couple times I used this tool, I came in, tried to use a line, the first surface disappeared, and I just kind of monkeyed around with these numbers, and I wasn't really sure what was going on. But what we want to understand here is that we've got a lot of control on what we can do, but we need to understand the inputs. So first things first, when we go and we click G1, just say tangency, that first surface goes away, and you'll notice that we get this basically this straight line. Now, the reason that we get the straight line is because our settings for degree and span in the direction that we're looking now from left to right is just set to 1. And so these two add up, degrees and spans add up. We have to have at least 1 in each. So that gives us a total number of 2 CVs, a start and an end. It doesn't matter what kind of spline you're using. If you've only got a start and an end point, you've got a straight line. And so as soon as we start to add more to this, in this case, degree 2, span 1, basically what we're saying is we've got a single curve from start to end, and we're adding 2 CVs. And so once again, these two are going to add together to give us our total. So we've got 1, 2, and 3. Now, if I add more degree, basically what we're doing is we're taking that curve and we're starting to break it up. Now, some funny things happen here. I'm going to go ahead and just add a couple more. We'll go all the way up to 5. But some funny things start to happen because as we look at this, you'll notice that the transition from tangency is relatively short here. Now, the influence by default, that tension value is 0.5. You can increase this if you want. What that's going to do is it's going to move that first set of CVs out tangent to our edge. And you can bring it back down if you want less of an influence, but you can kind of play around with that. But what happens here is that all of the curves that the CVs for the degree that we're adding are stacking up in that original surface. The way that we get this to transition throughout the rest of the surface is by using this blend extra rows section. And so what this is going to do, if we pay close attention to the 4 CVs that we got at the bottom, as soon as we add 1 blend extra row, it's taking away that last set of CVs and it's pushing it back up into the rest of the surface. Now, if we do this again, if we add 1 more, you can see that it took that extra curve, and then we go 1 more, and it brought the rest up. Now, there is a limit to this. At this point, we have taken, and if I roll this back down, you can see that stack of CVs at the bottom. So if we go to the point where we've taken all of those CVs and distributed them evenly across the entire surface, if we try to go 1 more, we're going to get a failed surface because now it's got to be straight. And so there is a limit. Again, a limit is going to be based a bit on your settings. So we have to have more degrees and spans than we do blend extra row. And so when this is set to 0, and this is 5 and 1, we've got 6 total. So we've got 1, 2, 3, 4, 5, and 6. And so we have to have one CV at the start where our surface is starting and influencing that tangency. We have to have a second one for G1 continuity. If we go to G2 continuity, now we've got two sets of CVs that are in that tangent direction that we must have. And so what this means is now we can only go to 2 for blend extra rows, because after 2, we don't have any more to blend. And so again, there's a relationship between all of these settings that we need to understand to be able to make work for our own purposes. And so now that we've got a little bit of a basic understanding, if we start to add spans into the mix, what spans are going to do is say, all right, well, we're going to take the start and this endpoint, and we're going to break it up into two individual curves. What ends up happening is those two individual curves still end up stacking at the bottom. And so we're going to blend extra rows. And again, you can kind of jump ahead and kind of push these up, but there is always going to be that limit where you must have at least two more CVs in the degree and spans, again, adding those numbers up, if you're on G1 continuity, or 3 more if you're on G2 continuity. And so right now, if I go up to 10 and I take this to 6, we've got 10 CVs spread across the entire curve, and we've got 6 blend rows. So if I try to go to 7, notice that the whole thing collapses. And that's because we need to have those extras to account for G2 continuity. We need at least, those extra couple vertices in there, the CVs. And so hopefully this gives you a bit more information on how this tool works and how you can play around with it and get it to work for you. In general, chasing the CV number with the degrees and spans with the blend extra row will give you the smoothest transition throughout the whole thing. You don't need to have large numbers to make that happen. And the number of spans and the number of degrees, so if we take these down, are going to have slightly different influences, but again, the total number of CVs adds up between them. So let's do an example. Let's go all the way back down to 0. I'm going to take the degree to 2. I'm going to go back to G1 continuity. And you can see in this case, with 5 curves, we've only got one CV at the start, one for G1 continuity, and then the rest of them are stacked up here at the bottom. And so we've got a straight curve at the start for G1. We've essentially got a straight curve between those two. And then we've got the rest of the spans that we've added here. And so if I increase that, again, you can see that they're kind of stacking up here. Then we can blend extra rows and start to pull them out into the rest of the curve. Now, if we blend, let's see, 8, 2, and 9, you can see that's a pretty good transition where it's carrying the tangency from that bottom original surface and then it's transitioning up here. But what if we flip that around and we made it degree 9 and span 2? You can see that this one is more of a gradual curve, more of a consistent arc. And again, the degrees breaking up the curve into a specified number of sections or CVs, and the spans is adding multiple curves to the overall thing. And so when you add multiple curves, you end up getting more flat sections. They're not really flat, but you end up getting more flat sections because you're sort of localizing that curvature. As we rotate this around, there are a couple more settings that we can just mention while we're here. These settings for boundary. So natural is going to allow the surface, basically the direction of curvature, to drive the outside shape. And you can play around with this a little bit by increasing the degrees and spans in that direction. So again, the UV, in this case, essentially in the X direction. Increasing that will change how that works. By going to normal, this is going to follow the edge of the original surface up here. So you can see that it's essentially curvature continuous along this edge. Next and adjacent, in this case, they're going to do the same thing. They're not really going to be much different. Most cases that I found, normal, next, and adjacent have done the same thing. So they're very unique cases where you might see, let's say, the edge of the surface is transitioning one direction. That might be a use case where normal and adjacent will be a little bit different. But again, natural is just going based on the tension of the surface, where normal is following the direction of curvature coming off of that selected surface. There is a hidden section here called partial alignment. This allows us to dictate whether or not we want to make the entire surface. And so you can see we can kind of bunch it up. This doesn't change the number of CVs. It's just going to bunch them up closer together on that upper edge. And so I'm going to go ahead and pull those back out all the way. But that partial alignment, again, by default, it's hidden. But if you click on it, you can kind of drive those things. And so overall, that is what we have for these XNurbs tools. And that's, again, square and the align tool. The align is going to be somewhat of a sacrificial tool. That original surface goes away, whereas the loft tool and the square tool are very similar in nature. Square tool giving you more influence over those internal CVs and how that surface is shaping up. The loft tool is just going to allow you to do things like the tension or the tangency influence, as well as the tangency type, G0, G1, G2. There is, of course, the XNurbs tool, but it's not really going to do much different than the square tool in this case because we essentially have a square patch. So there's not really much use covering it. But again, square, XNurbs, the align tool, also XNurbs, so they're studio only. Now, if you're looking to buy the studio license, we are an affiliate. So if you want to use the code LEAD10 at checkout, that'll save you 10%. And remember that you can also upgrade, but the affiliate codes, the discount codes will not work for upgrades as far as I know. It's only for new purchases. But if you have any questions or comments on this, please let me know. As always, thanks for watching, and we'll see you in the next one.